Hi there. Welcome to Labster. Today you will learn how elements are organized within the groups and periods of the periodic table according to similar properties and trends. This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click Continue to learn how to navigate through your mission. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you've played a Labster simulation? Perfect, then let's get started with your first mission. Find the lockers and open one of them. Raise your lab pad for more information. Find a lab coat inside the lockers and put it on. Now find a glove box and click on it to wear gloves. Then put on safety goggles. Raise your lab pad for more info. Enter the lab. You're part of an exciting mission today. Earlier this morning, a team came in to fix the periodic table that is hanging on the wall inside this lab. However, they missed a few of the element bricks that have fallen out of the table. Later today, some potentially new students will come by for a tour of the lab, and we simply can't let them see that the table is still broken. Will you help us figure out where the last bricks belong before time runs out? Click Continue if you're up for the challenge. Before we start the mission, we need to bring you up to speed with some important knowledge about the periodic table. Have a look at our periodic table wall. Isn't it beautiful? The Russian chemist Dmitry Mendeleev was the first one who created a table that helped derive the properties of different elements. The same idea has been used to develop the modern version of the periodic table, as you can see it here, which is an important tool for many chemists, nuclear physicists and other scientists worldwide. When you move closer to the periodic table wall and hover over the different boxes, you can see the full element names. On the floating screen, next to the periodic table wall, you can switch between views of the table. If you click the metal versus non-metal button, you can explore the three large classes of elements that have similar properties: metals, non-metals and metalloids. If you click the element families button, you can explore the 10 different families that the elements can be divided into, such as halogens, noble gases, or alkaline earth metals. If you click the flame test button, you can explore the results from other flame test experiments, performed on a series of elements. The color of the element on the period table wall is representing the color from the flame test. Click on the periodic table wall and explore it further. Raise your lab pad when you are done. Are you finished exploring? Great. Then let's carry on with your mission. We can sort the elements into three large classes with similar properties: metals, non-metals and metalloids. Click on the metal versus non-metal button on the floating screen to see which colors represent the different element classes in the periodic table wall. If you like to learn more about the element class properties, select one of the options below. Metals are elements that are shiny, ductile, and good conductors of heat and electricity. On the periodic table wall, you can see all the metal elements in blue on the left side of the table. Non-metals are elements that appear dull and are poor conductors of heat and electricity. On the periodic table wall, non-metals are shown in green and are located on the right side of the table. Metalloids are like a metal, which means that they conduct heat and electricity moderately well, and possess some properties of metals and some properties of nonmetals. One famous example is silicon, which acts as a semiconductor. Metalloids are shown in red in our periodic table wall. You can check out the Theory tab on your lab pad at any time to learn more about the three main element classes of the periodic table. Click on the highlighted labels on the periodic table wall to learn more. Elements in the same group have the same electron configuration in their valence shell. This gives all elements in one column very similar properties. We will learn more about this later. Elements in the same period have the same number of electron shells and tend to have similar properties. Thus, it is relatively easy to predict the chemical properties of an element if one knows the properties of the elements around it. A new row is started when a new electron shell gains its first electron. To figure out where the fallen out elements go in the periodic table wall, we need to observe a couple of their properties. Luckily we can do that here in the lab. What kind of property would help you categorize some of the elements? That's right. Observing properties such as the atomic radii, ionization energy and the electronegativity of an element will help us understand to which group and period it belongs and where it should be placed in the periodic table wall. Go to the hollow table to the right of the periodic table wall. Click on the blue buttons representing elements on the wall to the right, to see the element in front of you on the hollow table. You will be able to judge its size based on atomic radii and see information such as the electronegativity and ionization energy on the hollow table screen. Let's see if you can determine some common trends. Would you like to hear more about the definitions of any of the chemical properties? The atomic radius of a chemical element is a measure of the size of its atoms, usually the mean or typical distance from the center of the nucleus to the boundary of the surrounding shells of electrons. Electronegativity is a chemical property that describes the tendency of an atom to attract a shared pair of electrons towards itself. An atom's electronegativity is affected by both its atomic number and the distance at which its valence electrons reside from the charged nucleus. The ionization energy is the minimum amount of energy required to remove the most loosely bound electron, the valence electron, of an isolated neutral gaseous atom or molecule. All good to go then. You can check out the Theory tab on your lab pad at any time to learn more about different element properties. Use the square blue elements on the screen to your right to switch to another element. Raise your lab pad to continue. Are you finished exploring? Great. Then let's carry on with your next challenge. On the control panel on the wall, you'll also see a bunch of arrows. They show the direction of a trend, from a lower to a higher value. For example, an arrow pointing to the left would mean that this property tends to decrease when the group number increases, and vice versa. The direction of the arrows are not correct at the moment though, and each of them can be clicked to switch direction. It's up to you to get it right. Assign the arrows according to the trends that you see and click Submit. You can see the hollow table to validate your result. Well done. You managed to find the main trends in the periodic table. Have a look at the image on the lab pad to see a summary of the different trends. What do you think is the reason for an increasing atomic radius within one group? Genius. The increase of the number of electron shells within one group directly influences the atomic radius of the elements. What do you think is the reason for a decreasing atomic radius within one period? Correct. The atomic radii gets smaller as we move up in group number within a period because no additional shell is added and more protons are present that draw the electrons to the core. When moving from left to right across a period, ionization energy is increasing. By which other trend is this caused? That's right. The more tightly bound an element is, the more energy is required to remove an electron, and the ionization energy therefore increases when the atomic radius decreases. Electronegativity increases in the same manner as ionization energy because of the pull exerted on the electrons by the nucleus. Equipped with this knowledge about trends in the periodic table, have a look at phosphorus and neon and see if you can find any clues based on their chemical properties. Knowing the element's chemical properties might help you when you place them back in the periodic table wall. Observe the properties of phosphorus and neon on the hollow table. Raise the lab pad when you're done exploring. Are you finished exploring? Think about what you learned about trends in the periodic table and apply your knowledge by assigning the last two missing elements to the periodic table. Remember that you can always go to the Theory or Media tab to find the main trends for the explored properties again. Go to the periodic table wall. Assign phosphorus and neon to the periodic table. Raise the lab pad when you're done. Have you finished assigning the elements? You didn't get it right. Please try again. To place an element on the periodic table wall, click one of the elements on the floor to pick it up, then click one of the empty spaces on the periodic table to place it there. You can always switch back to the color map by clicking the Flame Test button on the control panel and compare it with your result of the flame test stored in the Media tab. If you placed elements in the wrong place, you can pick them back up and place them on the floor before trying again. Have you finished assigning the elements? You're a rock star. You have successfully assigned all fallen out elements in our periodic table wall. It seems we're all set up except for the atomic number. Let me unlock it in our periodic table wall. Have a look at the numbering in the periodic table. In the standard periodic table, the elements are listed in order of increasing atomic number Z. What do you think the atomic number represents? Spot on. The atomic number Z represents the number of protons and is fixed for every element. In contrast, the number of neutrons may vary, which creates the different isotopes for each element. Together, protons and neutrons make up the atomic mass. Note that in the periodic table, we can see the atomic weight, which shouldn't be mistaken with the atomic mass. The atomic weight, also called relative atomic mass, is defined as the average mass of all isotopes of an element as they are naturally occurring on Earth. The atomic mass is, therefore, a whole number, whereas the atomic weight would usually have several decimals. Right on time before our visitors are arriving. I heard that the first visitor is already on her way. Now that you became an expert on the periodic table, I'm sure you can answer her questions. One of the students is on the way and she needs your help to answer some of her questions.
Hey there, I'm so excited to be in a real lab for the first time. I wanna become a scientist one day. Chemistry has always fascinated me and I have a million questions. Can you tell me what the green color here in the periodic table stands for? That's really interesting. Krypton is my favorite element. Ever since I watched Superman for the first time. We also just covered electronegativity in class and I heard it's something that one can estimate from the periodic table. Which is the element with the lowest electronegativity? Wow, there are so many things one can see in the periodic table. Thanks a bunch for answering all my questions. I'm even more convinced now to sign up for a chemistry undergrad program.
Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.